Once we found a significant correlation between variables x and y, the next thing that would be good to do is to determine the line of best fit that basically tries to estimate all the scatter plot points to the best of its ability. So we're trying to find the best fit line here. And your graphing calculator can do that for you very easily. And in fact, we've actually already done this. We just haven't talked about how we've done it or where it is in the calculator. And we're going to do that right now. Okay. So obviously your best fit line or regression line isn't going to go through all of your points. It with real data, I mean, nothing really ever falls in a straight linear line. So the distance between the actual data point itself from the line of best fit is called a residual. And basically, the line itself, though, we can use to at least estimate what to expect y to be for a given x value. And it's not necessarily going to be 100% spot on, but it's at least a good estimate of what to expect. So going back to your days of algebra class, the equation of a line is y equals mx plus b. Okay, y is your predicted value given some x that you plug in. The slope is the m term, okay, and people usually remember that the slope is the term that always has the x right after it, and then b is the y-intercept. And your calculator is basically going to give you some form of equation similar to that. It may not exactly be in this form mx plus b. It might not say this is m and this is b, but it will give you the equation of the best fit line. And this slide shows how we derive, how we find the slope and how we find the y-intercept. But as I've said, the graphing calculator will do that for you, so there's no need to necessarily bother yourself with these formulas. And as you can kind of see anyways, they're very messy and not easy to use. So I'd rather err on the side of caution and just rely on having the calculator do it. As long as you can type your data in, you'll be okay. So let's use that example from earlier with the GDP versus carbon dioxide emissions, and let's find the best fit regression line. So we'll turn on the calculator, and if it's in your calculator already, we'll go to stat and hit enter. So my data is already into the calculator, but if you haven't done that already, then in column L1 you would type in everything from the GDP column here that's labeled X, and then column L2 is going to be your Y variable or the carbon dioxide emissions. So you type that into the calculator. And we're actually going to go back to click stat again, and we're going to go over to test and then go down and pick the linear regression t-test again. And we're not going to do anything differently here. We're going to leave the x list alone, the y list alone. We're not going to change anything on here. We're even going to leave it at not equals 0, just like we did for the correlation test. We're not going to change anything at all. We're just going to go to calculate. And you can see at the top here where it says y equals a plus bx. That's actually that's the equation of the best fit line. So all they've done here, though, is they've switched the order. Where you're used to seeing mx plus b, so they put the slope first and then the y-intercept. This equation says I'm going to give you the y-intercept first and call it a, and then b is going to be your slope, and it comes right after. So scrolling down here, okay, you see that it says a equals 102.289, I'm rounding, okay, and b is 196.152, and I'm rounding that. Okay, a is your y-intercept and b is your slope. So essentially they're giving you the equation of the best fit line in the same output. So really this best fit line is y equals 102.289 plus 196.152x. And if we go through the slides, okay, you can see like this is all the math that you have to do just to get to these to get to this equation. But essentially you see you get the same thing in the calculator that you would have gotten by hand, just a lot less cumbersome. And you can see this is the same equation down here as it is in the calculator. Just we're switching the order of where the y-intercept is. Okay, we're just flip-flopping the order. So they're saying that once you calculate the line of best fit, you could take 2 points and then just draw that line. We're not going to do that. But what we can do though is now that we know the equation of the line, we can plug it into our our y equals variable, and then we can use that to predict some points. So like let's say we have this best fit line, and let's say we want to know how much carbon dioxide do we expect to be emitted if we have a GDP of $2 trillion. Okay, we could type in 2 for x and basically figure out what do you get as a result for y. Okay, so let me go back just so we can see that equation again. Oops, too far. So there's that line of best fit, 196.152x plus 102.289. I'm going to go into y equals up here at the top left, and I'm going to type in that equation into y1. I'm going to say 102.289, only because that was the way it was typed into the calculator. They gave you the y-intercept first, plus 196.152, and then x is right here above the blue apps key. Okay. So once you've typed that equation in, it'll draw that line for you. And you don't necessarily need to see that line, but you could if you wanted to. Probably what's more important though is, like I said earlier, what if we wanted to know how much carbon dioxide is estimated to be emitted when you have a GDP of 2? Okay, if we plug in a 2 for x, what do we get for y? So if I wanted to do it by hand, I really could just take 196.152, multiply it by 2, and then add the y-intercept. I could do that in a calculator and just have it shoot out the answer for me, or do it on paper and pencil and get the answer that way. Or I could just tell the calculator, if I gave you these x values to plug in, could you tell me what I get for y as an answer? And that's pretty simple. We're actually going to hit the yellow key and hit the window key up here, and it'll say table setup. So we're going to go down to where it says independent. Where it says auto right now, basically the calculator by default will just plug in x values for you, starting with 0 and going up by increments of 1. We can actually change that from auto to ask and hit enter here. And what happens is, then when you go to hit yellow key and then the graph key, okay, you have a blank x and a blank y. What that means is you can type in the x value that you care about, only the ones that you care about, and once you type in that x, it'll shoot out the y result. So if I type in, for example, what do I get for y when x is equal to 2, I can just type in 2 and hit enter. It'll plug that 2 into that equation we typed in, and it'll shoot out what y is as a result. So when you have an x value of 2, when GDP is 2, the y variable is approximately 494.59. And if for some reason you need to see more decimal places for your homework, just arrow up to where y1 is, and when you highlight that value, you can see that you can see there's a third decimal place, just in case you need it for the homework. The only thing to keep in mind though is when you're doing typing in values of x to find what y is as a result, I would say that it's important that the x values that you type in fall in the range of the x values that you typed into your into the list. So for example, let me go back to the list for a second, hit stat and edit. Okay, my x values for list 1, basically the smallest value is between 0.9, sorry, is 0.9, the smallest value is 0.9, and the largest x value that we typed in to our data set looked like it was 4.9, and it is. Okay, so when you're trying to use the best fit line to estimate values for y, okay, the x values that you plug in should only be between your smallest data point and your largest data point. So like it is reasonable for me to assume that I could estimate a GDP of 2 because 2 is between 0.9 and 4.9. But if the problem said, well, what do you think the carbon dioxide rating would be if we had a GDP of 7? Well, 7 wasn't ever used to generate the best fit line, so it really doesn't make sense to estimate carbon dioxide off of a value that was never really incorporated into the best fit line equation. So now what I mean by that is it doesn't matter if the point that you're estimating for, sorry, the point that you're plugging in for x does not have to be a point that you've already plugged in to your list, okay? But the value that you're using for x should be between, like I said, the smallest value you put in and the largest value that you put in for x, okay? So it's okay to estimate carbon dioxide if GDP is 1.5 or 3, but it wouldn't make sense to estimate GDP if it was, 0.5 or 10, because those values fall outside of the range of x values that we plugged into our list. But other than that, I mean, that's literally how simple it is to um, do the best fit line with the graphing calculator. Um, be careful on your homework though, because the calculator shoots out. Let me go back for a second to linear regression. Your calculator shoots out the equation of the line in with y-intercept first, then the slope. So there's A. Scroll down. There's B. Okay, y-intercept, the slope. Okay. When you do the homework, okay, they might actually switch the order. They might actually want for the slope first. They might want B first, and then A. So be careful for that. Um, also, whatever equation you do end up typing into the calculator, or I'm sorry, whatever equation you get from the calculator for the best fit line, your homework is probably going to say round it to 3 decimal places. So whatever you type in for the equation of the line in your homework, use that same equation when you type it into y equals. Okay, exactly how it's typed in. And that's basically it. So hope that helped, and we can definitely talk about it more in class on Thursday.